During this lesson you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Foundations Part 2, Below Ground. Learning outcomes. By the end of this lesson you should be able to list the 4 main types of foundation, including where and why they are used. And 2. Sketch a section showing each type of foundation. Types of foundation. The 4 principal types of foundation are: number 1, the strip foundation. This is used for most domestic dwellings. We can see an image of it there in the bottom right hand corner. Also sometimes called a shallow strip foundation. Its minimum thickness there, our standard thickness minimum is 200, as we know from the previous lesson, as stated in the technical guidance documents part A, but standard thickness of the foundation is usually 300 millimeters. Now there are also variations on the strip foundation. Sometimes when the soil is not quite might not be great, might have weak soil or whatever. So the 2 other types of strip foundation we might see would be one there, the deep strip foundation, which we can see an image of it in the bottom right hand corner there. Deep strip foundation. This would be more economical maybe than having to put in a raft foundation or having to put in pile foundations, which have to go down much deeper. So these are used on weaker soil. So sometimes if the soil is that weak, we might have to dig down much deeper, and it's more economical to put in a deep strip foundation. The other type then of strip foundation that we might use would be called a reinforced wide strip. So if the soil again is quite weak, we might increase the width of the foundation so it has a larger surface area for the bearing of the weight of the building. And if we see in the image in the bottom right hand corner there, if we have a wide strip foundation, we usually include reinforcing, and the reinforcing bars would run across the width of the foundation, and they're always on the bottom inside the foundation, on the bottom of the foundation, and then they have connector bars as well running down either side in order to tie them into, so we have a nice structure when we're pouring the concrete in around them. That's the first type of foundation. Then is the strip foundation, the most common type of foundation used. Number 2 then is called the pad foundation. This is generally used on industrial units or what's known as portal frames. These are kind of like maybe factories or warehouses, so the whole building would be framed in steel or concrete, made up of columns, vertical columns and beams, or maybe roof trusses connecting from one column to the other. So the columns are supported on pad foundations, little square pad foundations like this. And again, this might be more economical than digging trenches all the way around, and then using maybe a strip foundation. The third type of foundation then is called a raft foundation, usually only used maybe on single-story buildings. Again, this might be used where we have soil that's quite weak. And basically what a raft foundation is it's just one continuous slab of concrete that's placed underneath the structure. Again, this might be more economical to use the raft foundation than to dig down very deep and maybe use deep strip foundation, or maybe having to use pile foundations, which we'll talk about now in a minute. So this might be a cheaper method, again more economical. So largely the choice of foundation is dictated, as you can see here, by cost and suitability, of course. But there's lots of different types of foundations that can be used for a particular situation, and that's why we usually go with whatever's the cheapest one or most economical. The fourth type of foundation then is called a pile foundation, usually used on multi-story buildings that are going to be extremely heavy, or on soil that's extremely weak. And again, this might be more economical to use the pile foundation than to have to excavate out a lot of soil, or having to excavate out loads of soil, because remember, everything we dig out we have to dispose of, and that has to be paid for. And if you've dug it out, you're going to have to replace it with something. So filler, whether it be hardcore or concrete, is going to cost money as well. So that's why sometimes the pile foundations could be more economical. Now, there are 4 different types of pile foundations. We'll just have a look at them briefly just so you're aware of them. The first one there is called end bearing, and this is basically where we'd either dig down or drive down our pile foundation, which would be like a column of concrete that would be driven into the ground, or we would dig it out and pour concrete down into the ground like in a column. And end bearing pile is where we dig down, or we might be digging down through lots of weak soil until we hit a firm load bearing soil. That's the end bearing pile. If it's a thing that the soil is really bad all the way down, then we might use this second method, which is called a friction or a floating pile. And this is quite rough and jagged all around the edges, and what it does is it relies on the friction that's created between the surface of the rough pile foundation and the surrounding soil or the surrounding ground makeup. The third type of pile foundation is called a replacement pile. This is where we basically drill a hole down into the ground and then it's filled with concrete. Sometimes reinforcing bars are placed into that hole as well before the concrete is poured. The fourth type then is called a displacement pile foundation, and basically this is where we have the pile foundation, we have the pile already cast, so we have a concrete column and it's driven down by force, by hydraulic pressure, driven down into the ground until it hits a solid ground, or for using the friction then until it goes down a particular depth. And these can go down 5, 10, 15, 20, 30, 40 meters into the ground. Okay, worksheet question 1. List the 4 main types of foundation, including where and why they are used. Now we're going to have a look at each one of these in a little bit more detail. So number 1, the strip foundation, usually of steel reinforced concrete. This is certainly for constructing buildings. We'd have steel reinforced concrete formed centrally under the load bearing walls. So we can see the example in the image on the right hand side. Shallow strip foundation, the most common type of foundation used. The width of the strip foundation depends on the bearing capacity of the subsoil and the load on the foundations. The greater the capacity of the soil, the less the width of the foundation. So basically, the more solid the ground is, the less we can reduce the width of the foundation. Another variation on that would be the deep strip foundation. Foundation depth increased, taking the base of the foundation to stronger load bearing strata, or to the depth where the moisture content of the ground is unaffected by seasonal variation. So these might be just some reasons why we might use the deep strip foundation. Excuse me. So deep strip foundation, we can see the image on the right hand side, used in a stiff clay subsoil. Another variation on that then is the reinforced wide strip foundation, used in subsoils with poor bearing capacity. Like I said, because this is why we might have to increase the width of the foundation, such as soft sandy clays instead of shallow strip. Steel reinforcing is needed in order to prevent shear failure due to weak tension in the concrete. So because we have an increased width, and we've already established from previous lessons that concrete is up to 14 times stronger in compression than it is in tension. So concrete is weak in tension, so the concrete is going to tend to try and bend, so we include the reinforcing bars there along the bottom. So on the right hand side we can see the image of the wide strip foundation used in subsoil with poor bearing capacity, and it's usually always reinforced. Just to look in more detail now at the steel reinforcing, and this would apply to all types of concrete that might have reinforcing in it. Concrete is strong in compression but weak in tension, like we've already discussed. So if we have a look at the image on the right hand side, the load is applied, which is the wall built on top of the foundation. So the downward pressure of the wall and the opposing force of the ground attempts to bend the foundation upwards. placing the top in compression and the base in tension, being torn apart. To add tensile strength, rebars, which is a common name for reinforced bars, are placed along the bottom edge. So we can see in the image there the rebars down the bottom, wide strip foundation reinforced with 12mm steel bars, and it's important here that all steel that's placed inside concrete, all reinforcing bars that are used in concrete, should have a minimum cover of 25mm of concrete. So this is not to protect it from moisture or anything, because the concrete is going to become saturated anyhow, but it's to prevent the bars from rusting. So in order for rust to take place, oxidation is needed. So basically oxygen is needed in order for rust to happen. So this is to prevent the reinforcing bars from rusting. So that's why we have a minimum of 25mm cover of concrete on those reinforced bars. Okay, worksheet question 2. Have a go there at sketching a section through a strip foundation. So we can see in this here, we can see the width of the foundation is going to be 900 and the depth of it is 300mm. And we can see the wall being built up on top of it there, the rising wall. So this is the strip foundation. Number 2 then, the pad foundation. The pad foundation transfers the load to a lower level where soil of sufficient load bearing capacity exists. So sometimes this is used because it's a portal frame construction. Sometimes it's used in order to dig down deeper than if we were going to use a strip foundation. It's used in conjunction with ground beams sometimes, depending on the makeup of the actual structure up above. So it's used in conjunction with ground beams in order to support the main walling of the building. So quite often these portal frames, we can see an example in the image in the top right hand corner there of the pad foundation, and then just below that there, like I said, is an image of a portal frame. So we can see the pad foundations on either side and the upright columns going up there to creating the frame of the building, and then we have our rafters, our trussed rafters there, sloped up for the roof. So we might have we'd usually have these spaced maybe every 6 meters, and then quite often we'd have cladding fixed to the outside of these types of buildings. But sometimes if the building is going to have brick or block walls built up on the outside of them, or in between these columns, in between these frames, then we'd use the ground beam. We can see the example of that in the left hand bottom image there on the slide. So we have a pad foundation, and then we have a ground beam running from one pad to the other. We'll see more examples of this in a short while. Okay, so worksheet question 2. Have a go now at sketching a section through a pad foundation. So what we can see here are 2 pad foundations there for the building, and we have again, these are 900mm square. They would be 900mm square, and then 300mm in depth or in thickness. Number 3 then, the raft foundation. So consisting of a raft of concrete under the whole of the building. It's used on compressible ground such as very soft clay, where strip, pad or pile foundations would not provide a stable foundation without excessive excavation. So again, we could use those other types of foundation, but it would mean we'd have to do a lot of digging, and like I said, for everything we dig out we have to pay to get rid of that, and we also have to replace it with something. So this is a more economical method. So you can see there in the top right hand corner the image there of the flat raft foundation. This particular one here is called a flat raft because it's the same thickness all the way through. Doesn't always go in like that though. Steel reinforcing runs in both directions under the entire building. So we'd have an entire mesh of steel reinforcing within the raft foundation. Raft foundation continued. Where loads require a thick, uneconomical flat slab. In other words, if the raft has to be extremely thick. It is usual to cast a raft as a wide tow raft. We can see the example in the image on the right hand side there. So instead of having the same thickness of slab all the way through, sometimes it's just thicker on the outside where the walls are going to go around the perimeter, and that way we can keep it a little bit thinner inside. So again, this would have to be calculated. This can also accommodate the external leaf of a cavity wall, as we can just see in the example of the image on the right hand side. So the makeup here, we can see there we have our starting from the top working down here. Just going to have a look at the image. So first of all, we have a 50mm sand and cement screed. That's sitting on top of the finished floor. That's the finished floor. Underneath the sand and cement screed, we have a DPM, or a damp-proof membrane, which is viscreen to keep the dampness out. Underneath that, then in this example, we have some rigid insulation board to keep heat in the building. Then underneath that, then we have our concrete raft with rebars or mesh. Sometimes road mesh is used inside the raft foundation itself. And underneath that, then again underneath the raft, we have 50mm blinding layer of sand or concrete. This is just we put in maybe a blinding of sand and get it perfectly flat and level, just to ensure that the depth of the raft is the same all the way throughout the entire slab. So worksheet question 2, sketch a section through a raft foundation. And we can see all the details here of the rebars for this particular type of raft, which is a section through a wide tow raft foundation. The fourth type of foundation, which is the last one, is called the pile foundation. So a series of columns constructed or inserted into the ground to transmit the loads to a lower level of subsoil. In the example on the right hand side, there in the image on the right hand side, there are 3 columns there. Sometimes there's only one pile. It depends. It can vary. It'll be down to the engineer to specify that. It's used in conjunction with caps or ground beams, which support the superstructure walling above ground and transfer the loads onto the piles. So we'd have the pile foundation going into the ground, and then usually on top of that we'd have caps on top of the piles. And then sometimes we'd have ground beams as well. We'll see another example of this now, in a more detailed example on the next slide, to show how that's done. So reinforced ground beam sitting on a blinding layer of sand. We see the details of this on the next slide. So that's a pile there supporting ground beam and superstructure of the building. So here we can see a cutaway section of our piles, which are driven down into the ground. On top of each pile, then we have a cap, concrete cap, and then spanning from one cap to the other, or it's like a little pad foundation sitting on top of the pile. Spanning from one to the other, then we have our ground beam, and this would be the reason we might use this is if we're going to have walls being built up above, as opposed to a steel structured building with just columns or whatever. And just a note there that the ground beams, they come with a 50mm sand blinding just underneath them, and that's just in order to make sure that the weight of the building up above is not being transferred onto the ground, because what it needs to be done is it needs to be transferred onto the caps, which in turn will transfer the load down into the pile and down to our good load bearing strata down lower that we've reached with our pile. Okay, worksheet question 2, sketch a section through a pile foundation. So we can see here we have our 2 piles, we have our cap on top, and then we have our ground beam cast across there with our 50mm sand blinding. So summary, in this lesson you covered the 4 principal types of foundation. One was a strip foundation, which is suitable for most domestic dwellings, probably the only type of foundation you'll come across. Number 2 there, the pad foundation, which is a single point support used on industrial units or portal frames, and again this might be just more economical and used for use on weaker soil. Number 3 there is a raft foundation, suitable for low-rise buildings, up to 2 story, for weak soil, and it would be more economical than using pile or deep excavations. Number 4 then is the pile foundation, used on all types of buildings up to multi-story, used for weak soil, again more economical than using deep excavations. So we also did a sectional sketch through a strip foundation. We did a sectional sketch through a pad foundation. We did a sectional sketch through a raft foundation. And finally a sectional sketch through a pile foundation.